Okay, cool. So I think we got enough folks to get started. John, do you want to take it?
Energy, a Mead and Hunt company, and I'll go ahead and introduce the event with Victoria Herrero-Garcia, our Senior Sustainability and Carbon Project Manager at Ambient Energy. Victoria has been here for over 5 years, is over 6 years now, I believe. And
6.5, yeah.
6.5. So she enjoys initiating embodied carbon conversations with design teams early in design and helps develop sustainability strategies to achieve carbon reductions. She is a co-chair of the Carbon Leadership Forum, Rocky Mountain Hub, and she also volunteers with the Carbon Leadership Forum, organizing webinars and the bi-monthly Global Happy Hour. In September 2020, she was featured as the Carbon Expert of the Month for WBLCA, which was one of the softwares we'll discuss later today, a tool to complete whole building lifecycle analysis. Victoria authored an article for the Technology, Architecture plus Design magazine called Whole Building Lifecycle Assessment, Comparison of Available Tools. She holds a bachelor's degree in architectural building engineering from Laguna University in the Canary Islands of Spain, and a Master of Science in Sustainable Design from Philadelphia University, now Thomas Jefferson University. Welcome, Victoria, and thanks for being here.
Thank you, John, and welcome everyone. And we are going to have a discussion. Hopefully at the end, we will have enough time for Q&A and talk about embodied carbon and everything that might come through the presentation or other questions that you might have. And thank you, John, for saying my last name properly. I have to say.
I'm learning Spanish.
I know. Okay, so let's get started. Presenter, that's me. Ambient Energy, as well, John mentioned, that is a Mead and Hunt company now. So we have been acquired by a larger firm called Mead and Hunt, but we still are kind of like a branch of the sustainability for them. So we still offer the same services as we always have, commissioning, sustainability, and building performance within the group. The main reason why we are here, Ambient Energy has always been working toward a resilient and regenerative built world. And that's why we like to push the envelope and continue to have these great conversations with a great group like you all. So the agenda for today is to cover the basics of what embodied carbon is. I will cover like different terminology for environmental product declarations and whole building life cycle assessment, and then provide some case studies and resources, and then the Q&A. So mainly for years now, maybe, or I don't know exactly how many, the main focus on reducing carbon in general with the built environment has been related to operational carbon, but the industry has started to realize that the operational carbon is all the carbon that it is emitted during the operation of that building, whereas things that we use, the materials that we use to build a building or a project, they have the impact, and once they are in the project, they are there to stay. So what is embodied carbon then? What forms that whole carbon emissions? And that will be from the extraction, manufacturing, transportation, construction, replacement, and end of life of all materials that are used in a project. The embodied carbon is also known as global warming potential, and the unit of measure is kilograms of CO2 equivalent. It can be by a square meter, by square feet, by different units, but is kilograms of CO2 equivalent. And the reason why it has the equivalent is because it includes emissions from all 6 main greenhouse gases. It's not just CO2. So why does embodied carbon matters in the global CO2 emissions by sector? You can see here the pie chart. Many of you might have seen something similar. The building operations accounts for around about 28%. The numbers come from data that it might be obsolete already, but is the best data that we have so far. And the building materials in the yellow portion accounts to about 21% of the total carbon emissions for the built environment. When we put it in perspective, I like to see like, okay, like give me an example. So for example, there is like the total, and this is cement industry, and that doesn't mean that is cement only used in the built environment, in buildings per se, but also in some of the infrastructure projects. However, the cement industry has like 8% of the total global emissions, whereas the aviation is 2%. So those are big numbers and why we should care. Furthermore, by 2060, it is expected to, we are expected to have like 2.5 trillion square feet more of a square footage in buildings. That is like building an entire New York City each month for 39 years. That is 468 New York cities. Then when we start comparing like, okay, how much is operational versus embodied carbon? So in a building as usual on the left-hand side, if nothing is done to that, the operational, then the embodied carbon is only a very small part of the pie. But when we have a high performance building, the operational carbon gets reduced, and therefore the embodied carbon impacts are even farther. So let's just recap. And here's our time. It's like we are now ready to accomplish great things. And this is the time to get all our efforts towards carbon emissions reductions. So there are embodied carbon regulations that they are happening across the nation. The yellow states are the ones that they actually have a bike clean legislation that has passed. Yeah, woohoo, Colorado. So we have other states that they are trying to implement policies, and it is quite a bit so far. Like every year keeps changing. So hopefully we'll get more states that they implement these as well. Other reasons to accomplish embodied carbon are based on rating systems rewards. So projects are trying to reuse material or even buildings, and they get credit for that. There are also options to reduce embodied carbon material by procurement, so specific to the products that you're gonna use in the building. And also we get credit for doing a whole building life cycle assessment. Then Architecture 2030 established kind of like goals for when we should have a net zero carbon within the embodied carbon emissions from materials. So by 2040, we should be at 0. By 2030, we should be at 65%, and by 2025 at 45. So if we're going backwards, it's like today, we should have at least 40%. I have not one project out of all the projects that we have worked, they have achieved that percentage. So we still need to do a lot. We still need to keep moving forward and have these conversations with the design teams. Another initiative is Structural Engineers 2050. So this is a commitment that structural engineers across the nation are also signing to reduce emissions by 2050 instead of the 2040 goal. This is a little bit more challenging because the structural elements also have like limitations right now, but the goal is to reduce as much as possible. And you might be all asking like, what can we do? So actually, there is a mechanical engineer 2040 commitment that just came out like not even this month. It was this October when it was released. And this is available in the Carbon Leadership Forum. You can look at the details, read more information there. And the goal is to follow these 4 steps right there. So establish a company plan, request low global warming potential refrigerants, request environmental product declarations for all mechanical equipment system components, and then participate in like how is going like quarterly meetings on what else can be done. And with more for mechanical engineers and any energy modelers or whoever is having this type of conversations, then the New Buildings Institute this year, also a few months ago, put a presentation together about decarbonization, the built environment. And they established like the 4 main goals to be those here on the screen. As you can see, 2 out of the 4, they are related to the carbon emissions with the low embodied carbon materials and the low global warming potential refrigerants. Why the refrigerants are so important? So when we put in the perspective, when I was saying the carbon dioxide and carbon dioxide, like the CO2 equivalent, is because the global warming potential on carbon dioxide was established at 1, and every other gas has different global warming potential. So everything to translate that into CO2, the methane will be multiplying it by 28, the nitrous oxide by 265. So it's 265 times worse than the CO2. But the levels in the atmosphere are lower. That's true. But that is where you come to the fluorinated gases, which includes the refrigerants, and the global warming potential is really high. Okay, so this is kind of like, the first part was kind of like what is happening, how is the evolution of embodied carbon in regulations, and what people are doing and why they are doing it. But the conversation cannot start without an understanding on all the little parts and pieces. So what is an environmental product declaration? The terminology for the environmental product declaration is kind of like, I'm sure many of you have heard of this, is the nutritional label. So it gives you the data and information for each of the impact categories, global warming potential, ozone depletion, etc. And it gives you the amount that, like, what is the impact of that product on the atmosphere. Then to develop an environmental product declaration, we need product category rules. So this is kind of like the recipe. If you don't, if everybody's not following the recipe for this environmental product declaration to end up with the same flavor and the same texture of my food, then I cannot compare really which one is better or which one is worse. So we need product category rules and make sure that every product is following them. The life cycle assessment is And I think I should switch those. So the life cycle inventory actually is the first part, is what you request from the manufacturer. What is the entire process of getting that product, the extraction of the materials, what happens in the manufacturing, how much water, how much electricity, where it goes, where the little parts and pieces come from. So all that is a life cycle inventory that then gets multipliers for the environmental impacts, and that is what it becomes to a life cycle assessment. So the life cycle assessment includes the life cycle inventory plus environmental impacts, and the final report is the EPD. Then within the environmental product declaration, you need a systems boundary. So you need to know what has been included and what has been excluded. And within the system boundary, there are life cycle stages, and we'll cover those here in a second. So the system boundary, many of you, I'm sure you have heard of cradle to gate and cradle to grave. So cradle to gate is the material extraction through the manufacturing, and once it leaves the gate of the manufacturing facility, it is out of my scope. Then for that systems boundary, the life cycle stages are A1 through A3. And that is more graphically how you can see the life cycle stages. So each life cycle stage is divided in modules. So the modules A1 through A3 is the life cycle stage for a cradle to gate product. As I was saying, for the life cycle assessment or the result of the environmental product declaration, you have impact categories where you find what is the environmental impact of your product. And here is an example. So this is, and I apologize, I should have looked for a mechanical EPD, but this is a concrete EPD on the left-hand side, and on the right-hand side is a steel EPD. So on the left-hand side, you can see that the Declare unit. So you remember that I said the global warming potential unit is kilograms of CO2 equivalent, but and you can see down there global warming potential and the unit. However, you need to know if it's a square feet, if it's a square meter, if it is cubic meters, sorry, and what is the unit. So this is what it makes it a little bit complicated, right? It is, I need to know the product category rule, I need to know the declare unit, and then the global warming potential, as is showing there on the steel. So when I want to compare them, which product is better than the other? So I need to know all these things. And it gets a little messy when I don't know what it was included also in the life cycle inventory and what is included in all the other stages. So for this reason, if you ever want to select different materials or different products that they do actually have EPDs, you can look on the EC3 tool. It's a tool that has a lot of different materials and EPDs. If we have time at the end, I can show you how it looks. And then one-click LCA planetary as well. So these tools, they actually give you, they compare, they already have entered the data there in the database to be able to compare products with the system boundary from A1 through A3, so cradle to gate. And also they have already checked that the declared unit is the same, that the PCR has been used, the correct one. So you are already just comparing materials without having to think anything else. So once you have your EPDs. How do you put them all together? Because it's a material here, material there, and the same for mechanical systems. Unfortunately, there are not many EPDs for mechanical systems, components, and equipment in general. So this is one thing that I would encourage to all mechanical engineers to request from manufacturers as much as you can. The industry started with not having many EPDs for a lot of products that they were very used in any project. And now we have EPDs almost for every single project out there, for every single product out there, or many of them. So when you put them all together and you actually do a further analysis of a building or a project, you need to compare. So the whole building LCA is comparing not one product against another, but is comparing a baseline of your building or your project against the proposed design. So how good is it doing against the baseline? The difference with the EPD, between the EPD and the whole building LCA, as you see now, the system boundary is including more modules or life cycle stages. It goes from A1 through C4. The life cycle stages here, again, we have modules A1 through A5. Before it was only through A3. Now it's including the transportation to the site and the construction and installation. Then module B1 through B7 is the use stage. So any replacements that need to happen while the building life, expected life, it's still on. And then the module C1 through C4, which is the end of life of these materials. There is a module D, which there is a lot of controversy with this module. And since the industry has not been able to figure it out, good methodology to be included into the end of life without double counting, most rating systems don't allow you to use module D to benefit the project, because it is like not always, in many cases, it is already included in the end of life, so in stages in module C. So again, the system boundary is A1 through C4. And now the system boundary is also called cradle to grave. So it's from the extraction to the end of life of that product. So when should I start talking to clients or design teams about embodied carbon and the whole building LCA process? So as soon as you can. I know that many of us consultants have the difficulty of engaging the design team in early stages of design. So at least if you can do it in a schematic design, that will be the best time to engage the team. Then do a second round before the end of construction documents to make sure that everything is included in the package. And then if you're doing any rating system documentation, normally we recommend to do it at the end, not at the end of construction, but after at least you have received all quantities from the contractor. So what tools can you use? So again, procurement of materials, EC3 tool or one-click LCA planetary, whole building LCA tools. We have 4 available tools: Athena Impact Estimator, one-click LCA, Tally, and the E-tool. The primarily used in North America are the first 3 ones. E-tool was developed in Australia, and although it is used in some parts of the US, it's mostly used in Australia and England. Here are the links for those tools and where to find them. In addition, Athena Impact Estimator is the only one that is free to users, but it has limitations on the database and limitations on like what can you include and what you cannot. So a few case studies, and again, please keep in mind that this presentation is mostly like structural and building enclosure, because that is the bulk of our work. When we work for rating systems such as LEED, that is what is required to be included. So one of our projects, we did specify the global warming potential limit for concrete. So we use the EC3 tool. You have for the EC3 tool, there is a very large database of concrete. We are very lucky also in Colorado to have at least 3 different concrete producers that have included EPDs for concrete in our area. So it was pretty easy to actually determine, instead of using the National Ready Mix Concrete Association average, we did use the state average. So the tool has a capability to show you the average, the conservative limit, and what is achievable. So we use the achievable limit of threshold. So we included that information in the specifications and drawings. The second case study was is a 1-story building. Sorry, it's confidential. It was approximately 12,000 square feet, and this analysis was an early concept design. So the analyzed options were a standard foundation with a steel roof framing, a standard foundation with wood roof systems, and then 2 different foundations with, again, the steel roof or wood roof. And the results were those. So obviously the brown line, it was the elevated structure and the wood roof. The reason why we did this is because early in concept design, we were able to have a conversation with the design team. We use the Carbon Designer tool that is within the One-Click LCA license. And this tool allows you to enter certain early information for the building and calculates the building enclosure and the structure. So this will be our baseline building, right? So when we were sitting down with the architect and we were showing them these results, we were plugging in numbers, and then we just show these. And we saw that the first thing that the architect was like surprised is like, what happened with the underground walls? And we were like, well, any concrete structure underground, like parking lots or anything that is underground, it has a huge environmental impact. The reason why, because it has a lot of concrete. And the reason why is because you saw the slide with the cement and the aviation, and the cement has a very high environmental impact and global warming potential. So the architect was, well, we need a crawl space. The only reason why we have underground walls is because we have a crawl space that is required by code. But if we elevate the building, then the underground walls are gone. So we lost, we went down close to 16% down on embodied carbon, only taking away the underground walls. So then we were like, okay, so now what is the next one that we could tackle? So we went to the roof slab, and we saw that that roof slab was made of metal deck and concrete, and the insulation R value was of 30. So we needed to meet one of the requirements for whole building LCA is that the building enclosure has the same optimized energy performance than the proposed case. So we needed to make sure that that was the case. So we went to look for a wood frame with the same R value for the insulation. So this is pretty basic. We're not going to specific materials or insulation types or anything, just a generic value, right? And we saw that suddenly this roof slab went down really low, that our embodied carbon went down to more than 45%. So that's why we compare these 4 different structures with all these different options. Okay, so now to cover like what rating systems are doing and what the requirements are a little bit. So, and mainly because right now, if it's not by regulation, projects are doing this because of a rating system for the most part, unless you have it implemented as a process in your practice. So for LEED requirements, there is the MRC1 option 4 credit, which includes the system boundary that is cradle to grave, and the 60 years building life cycle. So the assumption that your building is going to be there for 60 years. So the end of life will be after 60 years. The elements to include on LEED, in LEED is the envelope and the structure. So, and anything that is included inside of the building as finishes, they will not be part of the calculation unless it's part of the structural floors and ceilings. Then all those finished will not be included, sorry. The cladding, the structural wall assembly, sorry, I said it wrong there. Optional elements which don't give you credit, but you can analyze them, is interior non-structural walls and interior finishes. They do analyze all environmental impact categories as well. And you get points just by conducting a whole building LCA, you get 1 point. Path 2, if you achieve 5% reductions in global warming potential and 2 other impact categories, you get 2 points, 10% reductions and 3 points, and achieve 20% reductions in global warming potential and 10% in other 2, and reuse or salvage some material. They don't give you a guidance of like how many square feet or how much in volume of this material needs to be reused or salvaged. You just need to use some. The difficult part is that it needs to be included into the building enclosure or the structure, and not all projects are capable of doing that. And furthermore, with the LEED, also there is a pilot credit that is the procurement of low carbon construction materials. And this one gives you credit for selecting materials only from A1 through A3. So it's only for procurement without including all life cycle stages. The materials are listed there. And to document this credit, you can use the EC3 tool, which is already free for everyone to use. The zero carbon certification from the ILFI has the same system boundary, but the life cycle of the building is 50 years instead of 60. The difference also with LEED is that you do include the interior non-structural wall and interior finishes in the calculations, not just the enclosure and structure. And also that you have to reduce the embodied carbon, and also it gives you by 10%, and also it gives you a limit per square meter, sorry, which is 500 kilograms of CO2 equivalent. So now you're like, okay, I'm a mechanical engineer, or I do energy modeling, or how can I really help with these? And what can I do to get involved in this process. So if you're in the Rocky Mountain area or Denver area, like the Colorado state, and you're interested in knowing more, we do have bi-monthly meetings with the Carbon Leadership Forum Rocky Mountain Hub. If you are not located in Colorado, look in the Carbon Leadership Forum hubs, and you might find some other hubs that they hold meetings in your state. Then I will encourage you all to, salud. I will encourage you all to sign the MEP 2040 commitment. Look in the carbonleadershipforum.org and read the commitment and what you can do. There are also a video that is called Inviting MEP to the Embodied Carbon Party. So this has more detailed information for you all. And also there is an article, and it's not an article, it's a white paper. It's more than a white paper. It's a little booklet that is called Embodied Carbon of Building Services Equipment. It was completed in the UK, and a study in the UK, but it is applicable to many mechanical systems. So I will encourage you all to look at that information. How we can help you or your project. So if you actually have a project that is interested on these topics and you just need someone to talk to them, please let us know. We'll be happy to do an introductory meeting of what embodied carbon is, do any research. We do the whole building life cycle assessment. And we would love to help any project or any of you to set up carbon reduction goals for your firm. Here are more resources with the Carbon Leadership Forum resource library. There are webinars. There is way too much information to cover in days, but there are great resources for you all to look at. And with that, we'll go to some questions.
All right, great. Thank you very much, Victoria. Awesome presentation. I'm going to, I don't see any questions in the chat, but if anybody did have any, excuse me, anything that they wanted to ask, you should be able to unmute yourself and ask that over audio or type in the chat if you're more comfortable with that.
And I will love also, since the group is not that big, we're like 28 people. If you all want to also turn your cameras on and ask any questions.
I'll ask questions. Yeah. Go for it, Joel.
Okay, all right. Well, okay. So this is Joel Nymark here at the in-person session. By the way, I'm glad we're starting to come back in person. I guess I had a couple of questions that I was scribbling while you were presenting, Victoria. And by the way, thank you. That a lot of food for thought there. And yeah. So one of the things, you talk about whole building life cycle assessment, and my sense was that's in terms of, like global warming potentials or relative global warming potentials. But I was starting to wonder about the costs of, going to some of these alternatives. And have you done, maybe I missed something in the presentation, but have you done, some of these, like the cost of elevating a building versus, a standard foundation, and then what that carbon savings costs versus, typical life cycle cost analysis, right? Heating system efficiency improvement and, that sort of thing. That's kind of a long convoluted question. But,
Yes, that is a great question. Thank you, Joel. So we don't do the cost estimating of the system that we propose, but we do have the general contractor when is on board in such a early design stages. So there was, for example, for this specific case study with the eliminating the crawl space, and the reality is that at the end, like you're saying, yes, increases the cost, and also the project is elevated. So now you need a ramp, or you need another form of entry for ADA, and there are other things that they start playing into the equation, and yes, the cost might be increased, but some design teams and owners, they decide to swallow, not to go with the incremented cost for the benefit of what they are actually trying to accomplish, because they do have sustainability goals. So it plays in both ways. So some owners will have like a very clear goal set of reducing this much for X projects, and if it has an increased cost, they will cover it. Other projects, they see that increased cost and they just don't do it. And that's most of the projects, to be honest with you. With there's a case study that I'm presenting with KLNA. We do have a presentation together. There's a structural firm there here in Denver. So they have a case study about a high-rise office building that was mass timber. So they did an analysis of concrete versus steel versus mass timber. And in different scenarios, like the cost per square foot, it was more expensive to do the timber. There were like 2 or 3 different things that it was more expensive to do it. But when they did see how much time it would take to do the mass timber versus the concrete, for example, the mass timber won. So in the timeline of the project and the labor that you were going to use and how fast you could have that building height built, it was worth it. So they ended up doing. So the cost at the end of all those studies, it was still a very little difference, but it was not significant enough to not do it.
So you're saying there that the timber material costs more than the more carbon intensive concrete, but the labor associated with the installation associated with the timber versus with the concrete was less.
Mhm.
So it might have, so that might have been a wash.
Yes,
Without seeing the numbers.
Yep. And the time, like, yeah, because the concrete, like, you cannot go to the next level of your concrete and start putting your columns and your slabs until it has cured in a certain amount of time, and then put weather conditions in Colorado too. Like if you're in the middle of winter, if you're in whatever stage you are, that will not happen with mass timber. You just go and put it up, right? So at the end of the day, it was worth it. Great question.
Okay, let's see. So we do have some other questions that are in the chat as well. Sorry, Joel.
No, that's what, I'm used to that chairing sessions. I store some things, but if other people have them.
Yeah. Victoria, can you see the chat?
Yes.
Okay.
Can you talk more about how to establish a baseline for embodied carbon reduction studies? Yes. That is a great question too. So the industry or even rating system is like a standard construction. That is pretty much what they tell you that it should be. So for structural engineers, what is a standard construction for a project. So in many cases, the baseline ends up to be what the design team has the idea for during a schematic design, I would say, because they are already thinking on not utilizing the concrete and steel that they're going to be using. So the cost is minimized. So they are already shrinking things to make it cheaper, right? And more affordable. So what I would suggest is that you always go to the schematic design or the structural concept design package, and you start using that as your baseline for the structure. For the building enclosure, ideally it would be kind of like, okay, if you have ASHRAE 90.1 baseline and then you compare it to your proposed case, well, it would be great if it was that way, but LEED and other rating systems require that your building enclosure has the same energy performance as your baseline and your proposed have the same energy performance. So the only way to meet that is that your proposed design is the baseline of your building enclosure. So when you start with that baseline, then you can do changes to the insulation, changes to the cladding, changes to whatever other material is part of that building enclosure, or selecting different glazing types that they have better EPDs, which also meet the requirements of the energy performance that you are utilizing. So it is still not concrete science, unfortunately, for many whole building CA practitioners. And the numbers we are trying, that's why all these commitments are coming out. We want to know what people are using for baselines, and we want to find a way to standardize, like, okay, for Colorado, this is your standard construction. For whatever state you are, or per state or per type of building, whatever it is, but try to standardize in a better way, the same as energy modeling is right now, which creates less. No, no, I'm not saying that energy modeling is a perfect science with all the results are perfect, but at least you have a clear understanding of a baseline and a proposed case and how you compare them. So hopefully with people committing to provide information about their baselines and their how their methodology to determine those baselines are, we'll get there to have a more standardized version. Then why nobody wants to ask the question? Pedro, unmute yourself and ask me a question. Or they cannot unmute themselves, can they?
Should be able to.
Should read the question, I guess.
Pedro, do you don't want to ask the question? I'll read it. So for lead, credit, pilot, nice, and you have a keyboard with the tilde. I like it. It is valid to use the EC3 tool for projects in Latin America. I think that the impacts in data sets for user are very even. Yes. Okay, so the EC3 tool is true. That is actually a more US database than the than for your case to find products within Latin America. However, I would suggest that you also check the one-click LCA planetary tool, which is also a free tool for you to use. And you might find more databases, more products within the database. If you don't find products, you do have the option. I can talk to somebody in the EC3 tool to see if they are going to start that, spending outside of North America and see if they will include more products from Latin America. But there is an option for you to request EPD or to request an EPD to be added. So if you do have a product that you want to use in a project and it is not included in the database, there is a button within the EC3 tool that you can actually request that. So search for that, look for that. And if you have any questions or if you need further assistance, just send me an email. I will send a PDF to Aaron and John of the presentation. So you will have my email. I can also type it here on the chat and I'd be happy to help you. But check the one-click LCA planetary to see if they have more.
Victoria, I had a follow-up question on the same topic. So this is Gokul here from Andrel in the in-person session again. So with these different tools, Tally, Athena, and EC3 and OneClick, do they use the same database or are they similar? So how do you account for consistency when you're using different tools?
So that's a great question. No, they don't. Yes and no. So there's some EPDs that they were very generic and industry wide, and they are accessible in all databases within each of those tools. Not all tools have the same databases. One-click LCA is a Finland-based software. So it started in Europe. So their databases started within Europe and then expanded to worldwide. Right now, the most extensive database out there for EPDs at this moment, it will be through the one-click LCA software. Athena has limitations to certain EPDs also being included because it's a free tool and also is actually from Canada, and they do have certain cities with North America. So even like transportation and so the whole building LCA does an analysis also with the installation and the construction and the transportation based on your location. So it will use the electricity data from Colorado if it's Colorado, from New York if it's New York, and Athena only has a few cities as locations. So if you will have to select the closest to where you are in order to do the analysis. So there's a lot of like differences between all the tools. John mentioned it, but I wrote an article with the TAD magazine that it talks about all the differences between the tools and the pros and cons of using one or the other. Also, they have different integrations with different models. So for some tools, you need a Revit file in order to do the analysis, for like such as Tally. And for others, you can use an Excel spreadsheet and upload it with your quantities and your information, and then get the results such as Athena and eTool and one-click LCA.
Thanks.
Yeah, great question. I don't know if oh, Pedro. Well, you could have asked me in Spanish if you wanted to. We can talk another time, Pedro. Feel free to send me an email. Or no te preocupes, mándame un email cuando quieras.
That's awesome.
Oh, hold on. I did not send it to everyone. Everyone in meeting, I didn't say. Okay, Hi, any suggestions? Did I miss any questions before that, after? So that's EC3. Okay, so that's EC3 provide performance values. Hayati, I think, I don't know if I pronounce it right. You want to ask the question?
Hey, can you
Oh,
hear me?
hi.
Hi.
Yes.
Okay, so this might be a very small question, but I just started working on EC3. I haven't used it much. So I wanted to ask if they do provide some performance factors like R values or U values, because I was trying to like choose something on my project, and then I had to go somewhere else to like choose something for the embodied carbon. So how does it work? Like, should I pick a product from EC3 and then search it on the official manufacturer side for initial design stages?
That is a great question. So you, in order to, let me share my screen again. Share a screen here. So share, since we have some time, I'm gonna show you, let's see, where is the sign-ins here? Okay, so this is Building Transparency is the website. You need to go and create an account for free, and then you can sign in to the tool. So here is how it looks, and so there is like, here is showing, so Pedro, for you as well. So it depends where you are in Latin America. So there are EPDs actually from Mexico. There's some, well, Brazil apparently has a lot of them too, and very little on from other countries. But here is like where the bulk of these EPDs are coming from. And this is the database of like, okay, here's how many EPDs we have for each of these different products. And Hayati, I'm going to your, the answer to your question. I'm just showing everyone else a little bit about these. So you can see like for concrete is the one that we have the most, but there is still a lot of like product specific and industry EPDs. So we have quite a bit of work to do for some of the other products, but we do have a lot of information for concrete finishes, etc. So when you go, so when we go to thermal moisture protection, and we go here, and now I'm gonna have to move this. I have you all here. So next, and we can select, again, I mentioned like we can select the location on the, where we want to do. So Central America, it looks like there's some here, Pedro, but for certain products, you will have some more, for others you have less. But let's go to the US, and here we're gonna have to scroll down and search. And so for each product, we'll have here like what is the product that we're looking for. So here, for example, roof cover. So this is roof cover. Let's find something that will have an R value. Owen scoring, heavy density, insulation. So here, for example, so we get to the details, and on the details, we can look, oh, now it doesn't, oh, here, open, sorry. So if you do click on the open instead of the details, Hayati, it will bring you to this page if it opens. And here it tells you more details about that product. So here is the declared unit, and it tells you with thickness, so that our SI is this. So it gives you more information if you go there without having to go to the manufacturer. This all this information comes from the EPD. So what the developers of the EC3 tool are doing is that if the EPD has that information for the product that you're looking for, it will have it here in that tab. You click open and you will have all more details about that, and then the product description, and it will give you all the details. If the EPD, here is again the PCR, product category rule that was used. So if the product EPD doesn't have that information, then you will have to go straight to the manufacturer and look for it. But some products, they do have it.
Right. All right. Thank you.
Yeah. Okay. Let me stop sharing unless anybody else have any other questions with the EC3 tool. We can look more at that. Okay, let's see. So the other question, Gavin, what was that? Sorry.
There was one at the bottom, but you might have seen one. That we didn't see.
Yeah, I saw Gavin is his name or her name. I'm sorry. Do you want to unmute yourself and ask the question? Okay. So the question is how to perform a LCA without construction material bill of quantity. So in many cases, you don't have the construction material bill of quantity coming from the contractor and until it's the end of construction or through construction phase. So for the most part, you will get all the bill of material quantities through the Revit file. For early concept design, you will need to ask a square footage from your architect and quantities and volumes from the structural engineer. Some design teams are not willing to do that. So you make assumptions based on the square footage or using the carbon designer tool from the one-click LCA. We do use that based on the square footage and the type of building. So that's how we get quantities when we don't have them. Making assumptions is pretty much when you don't have anything. And if you do have a Revit file, I would suggest that you just get the quantities from there.
Okay, thank you, Victoria. I was
Great.
trying to grab my earphone, so I didn't understand my question earlier. Sorry about it, but thank you for your answer. Thanks.
No problem. Thank you. Great question. Erickson, you have 2 questions. You want to unmute yourself and ask?
Can you hear me?
Yes.
All right. So 2 questions right now are there any manufacturer proprietary issues with their materials in that they don't acknowledge all of the materials or chemicals and whatnot that are going into the materials that they create, the products that they create, and therefore you would end up with incomplete data?
That is a great question. So yes, that is why we do have the product category rules. And that is the only way to really find out if a manufacturer has followed the ISO standards, and therefore the EPDs should be able to be compared and included in the databases. So every single software developer for whole building LCA or the procurement, so the EC3 tool and one-click LCA planetary, they do a thorough analysis of the EPD before they include those in the database. So to answer your question, yes, you can have some EPDs out there that they are not meeting requirements and not following ISO standards or product category rules. But if they are included in any of these databases, you can be assured that they are meeting the requirements.
And the following question is regarding the databases. So I've been doing some LCA off and on for the past number of years, and there are a number of free accessed databases, as well as a whole slug of them behind paywalls. Can you recommend any go-to places for free data?
So as of right now, I will again say the EC3 tool and the one-click LCA planetary will be the best options for finding EPDs that they are available within the region or the country. One-click LCA planetary even includes databases for products within other countries, so yeah, it is more extensive. And then it is, I have been in the same situation there, Erickson. There is like some, I always say to go to the manufacturer straight, like ask the question to the manufacturer, because at the end of the day, many of the free databases are updated by the manufacturer itself. So if I am a manufacturer and I just develop an EPD or just update it because my EPD expired after 5 years and I paid to get it ready, I will have it on my website. Then maybe 6 months or 2 months, depending on how I am busy or not, I will update the other databases. So they lack on making the updates right away because they don't get paid for it. So it is unfortunate, but.
Mm-hmm. And one last question regarding the software. It seems like a lot of these products use the same methodology. So are we looking at front ends for a methodology regarding the software choices, or are there actually black boxes that we'll have to dig into in order to understand the individual software's methodology?
That is a good question. So not all, like, to really fully understand how everything is operated, the transparency of every software is a little bit different. So at the end of the day, almost all, they offer you the capability to change in certain parameters, but not within like an EPD, for example, or like the product is the product and they're not going to let you change it unless you change the product. But then the localization, so where that product is coming from. So I have the same product that is manufactured in 3 different states, and I want to select the state that is the closest to me. So there's some that they allow you to change that distance. There are others that they actually have the EPD for each location. So you will select the EPD that is applicable to that. There are also options to change the electricity grid that you're using. Their capabilities, like I'm talking, most of these capabilities are within the one-click LCA, is the one that allows you for more adjustments or changes to be more accurate with your LCA. But you need to be kind of like an expert level of understanding how changing the electricity grid for a specific thing is going to affect the results of the overall whole building LCA, because not always you can do it in a way that it will make sense. So the long story short is that if you really want to understand how to use every tool, is like the more you use it, the more you get used to it, like any other energy modeling also software. But also trying to talk to the developers and understanding the different things that you will want to play around with, and understanding which one gives you that and which one doesn't.
Okay, thank you.
Yeah.
I had
you.
more follow-up questions on the database. So just one more. So has there been any concerted efforts by the CLF or ASHRAE or someone else in order to define a standard database? Because the way I see it, if every tool is using a different database and they're from different countries even, there's a lot of room for error.
And yes, that is a good question, but it's not that the database is different, it's that the database is more or less complete.
Gotcha.
So it is not that the same industry-wide EPD for steel in North America, one database like the EPD in Athena has a different global warming potential value that the EPD included in one-click LCA. No, that EPD is the same and it will be included in both databases, in both softwares. The only difference is that some softwares have a larger database than others. So you can be more product specific than using industry averages.
Awesome. Thanks for clarifying.
Yeah.
I think that's it for the chat. Do you have another that you wrote down, Joel?
I've got a
I
couple.
think
yeah.
Philip wants to ask a question, but I think you're muted or we cannot hear you. Nice background, by the way. Here you
Sorry,
go.
I had one mute button was unmuted, but the other one was still muted.
Nice.
A little virtual background. This is Pichikin, mascot of my company.
Nice.
I wanted to ask about the operating carbon calculations and just kind of what's current state on taking a product where you may have an EPD that has, I'll say, a generic operating carbon, say an assumed operating case, and then how does that get applied to an actual building? For example, maybe the system, the equipment is only used half as much or twice as much, and then makes a big difference in the actual operational carbon. How is that handled in some of these tools like One-Click or EC3 and so on?
Okay, that is a good question. Most of these tools don't do any operational carbon calculations. One-Click LCA does have the operational carbon calculations capability, but is independent of the embodied carbon. So it's like you're using an energy model within the same tool, like per se, not the same thing, but it calculates the operational carbon in one tab, let's say a spreadsheet, and is one tab with the operational carbon and the other one, it will be embodied carbon. So you can have the overall global warming potential or carbon emissions impact from your project when you add up together both operational and embodied carbon emissions, if that makes sense.
Okay, great. And just a quick reply to the prior commenter at the in-person site. ASHRAE has started a task force for building decarbonization and are taking a look into some of the same questions, trying to decide what role ASHRAE can play.
That's awesome. Good to hear.
Victoria, I had a question. Are there any, I guess you could call like low-hanging fruit that people could reduce the embodied carbon without increasing the cost, like say, just like by changing the formula for concrete or by adding fly ash and steel or using a different type of insulation?
Yes, don't demolish and build something new. That is your best low-hanging fruit. So yes, building reuse will be the best option out there. And then the next step will be to engage. So it is an interesting question, John, because so if you do have a normal structural a normal building with a structural system that is concrete and or steel, then your building enclosure becomes like very teeny tiny part of the equation compared to the structure. So the structure is like maybe 80% or more of the embodied carbon of your entire project. So then it's like, well, changing the insulation or changing the insulation, it doesn't make that much of a difference if the structural engineer is not changing anything. So the low hanging fruit there will be to do changes to the structure first, because if you do anything to the building enclosure, it will not affect. When you have a mass timber project, then the embodied carbon of the structure is very little compared to a concrete or a steel project. But then the building enclosure insulation, that will be the biggest impact out of your building enclosure there, it becomes a really big part of the equation. So it always depends on what the whole building, that's why it's the whole building LCA, because it's like you're looking at different parts and pieces and which one is the one that is going to affect the total of my embodied carbon. So it depends on the type of a structural system. I will say that you will use different strategies for the low hanging fruit.
Thanks.
Sure. Any other questions?
Yeah, another one you want to
My
ask?
last two are really general. I can go back to the general questions. Early on, you had a slide, pie chart about the different ways that embodied carbon breaks out. And I saw one of the items was building operations was 28%. So I was curious, I mean, is that hardware that's related to building operations, or what was that? What comprises that chunk?
So that slide, so the entire pie chart is CO2 emissions, CO2 global emissions in general. So there is like transportation and building operations, and then the materials, and then their infrastructure.
Can you put that on the? Can you put that on the? Again?
So there are a lot of different emissions coming from different places. Let's see here. So that, whoops, let me share first. Share screen. And here.
Causing trouble.
No, it's okay. I was just not ready for it. Here. Okay.
Yeah, that one.
Yeah, so this is so here is the global CO2 emissions by sector. So when you think about the and this is EPA data, and that was put together, adapted from the global status report from global. So people start making their own little adjustments, but the data comes from the EPA at the end of the day. And the latest, I think, global emissions report, it might have been, I don't know, 2018 or before. So it's not that accurate. However, they divided in different pies for this purpose, for talking about embodied carbon. And in this case, it was just like non-building manufacturing, then building materials manufacturing, building operations. So you can see that it's very focused on buildings. Other sector will distribute the pie in another way. But what it wants to tell us is that out of the entire global carbon emissions, 28% are from building operations. So that is the electricity or the natural gas or any sources, electricity sources that is being used for this building, right? And this is just manufacturing of building materials. So that part of the pie is the embodied carbon of building. So that's why it's separated that way.
So,
Yeah.
okay, I see. So then to summarize, then if a little bit of that transport percentage spills over into the materials and other building manufacturing, then about half of a building's lifetime energy use is associated with its embodied carbon. Is that kind of a way to interpret? Or half
Yeah.
of the building sector's energy
So
use?
half, yeah, so half it is the built environment per se, together with the building operations and the embodied carbon. So about half, not, yeah, close to half of the pie is from building sector.
Right, and then half of that half is embodied carbon.
Less than half, yeah, the 21%. Yeah,
Yeah, I'm just thinking
Yeah.
some transport's gonna spill into there, so.
yeah.
But just roughly, that's okay, great, that's substantial, that's. Right. Okay.
He's ready.
I was having a little trouble interpreting that pie and wanted to come back to it.
Oh,
So
yeah,
Yeah,
no problem. I want you to be ready to tackle this.
I think a previous presentation I saw you give, Victoria, you showed a similar pie chart where basically embodied carbon counts for roughly the same amount as your building operations. So like, embodied carbon kind of gets neglected. People spend a lot of time on their energy modeling to reduce, carbon emissions, but a lot of that also could be saved from embodied carbon, about the same amount.
It depends on the type of building, and if it's a high performance building, and yes, it can become half of the pie. Yeah.
Yeah, this tells maybe a little different story than the other pie chart.
Right.
Mhm.
Yeah, so you can think of the last pie chart as just like the entire building sector, right?
Yeah.
Good buildings and bad buildings average out to about that,
Residential
60-40
and
split.
commercial, all that.
right?
Mhm.
And then as you design better buildings, then it's going to use less electricity and other energy over time, less operational carbon, but you still gotta take a lot of carbon to build it.
And if you account for the grid getting greener and possibly at some point having an electric grid, then the operational carbon really disappears per se, and the embodied carbon is the only one that is there. And once you build your building with the operational carbon, you have a wiggle room of what is going to happen in the future. If you install PV, if the grid gets greener, if you upgrade for new, better mechanical systems. But with the embodied carbon, until you do a full remodel or demolish that building, that is there. It's not going to change.
Cool. So bring it back to the importance of the problem.
To wrap it up, yeah, that is good. I don't see any other questions on the chat. So does any other person wants to or make any comments? Like, please tell me, like, yes, I'm ready. I'm gonna fight for this, or whatever you want to say.
Hi, Victoria. This is Webavi here. Thank you. This was a great presentation, and thank you for answering my question about the baseline. I just had like another question, like, do you have any example studies or reports that we could like examine further, like, study further?
That is a good question, and you're welcome anytime. If you have further questions, please send me an email. But so the Carbon Leadership Forum, we do not have like white papers or like a report that we have put together company-wide. We only have the data from the projects that we have done, whole building LCA. So the Carbon Leadership Forum does have a resources page that they are starting to include a lot of case studies. So search for that. And if you cannot find it, let me know. But there is I believe there is already at least 3, if not more. I haven't looked in a while, but I know that there is some case studies already available there.
Okay, great. Thank you.
Yeah. You guys are all so serious.
All right. We have a few minutes left. Any last questions or comments before we wrap up?
Thank you, Philip.
Thanks for doing it, Victoria. That was really
My
informative.
Thanks, Victoria.
Anytime, my pleasure. This is my favorite topic ever, so. Okay, well, thank you very much for attending. De nada, Pedro.
And thanks to all the attendees for joining us for our little Denver group here.
Yeah.
It's great.
Thank you very much. Well, I guess wrapping up, have a good night, everyone.
Yep, thanks.
And a good weekend.
We'll
too.
end it there unless there's any more questions. So.
Okay. And Victoria did type her email in the chat in case anybody missed that, if you do have follow-up questions.
Yeah, I can type it again. And I don't know how you do with the distribution of I can send a PDF to John and.
Yeah, we should be able to have a list of names and emails for the attendees, and we can share any PDFs or other documents from Victoria that way.
Okay, thank
All right,
you.
well, thanks so much, Victoria, and have a good night.
You too.
Yes, thank you.
Thank you.
Cheers.
Bye.
Bye.
Bye,
Bye.
Linda.
Bye, everybody.